If you are new to the channel, then subscribe the channel and press the bell icon for further notification. Okay student, welcome you all once again to lecture 3 of this protection series. So today I have taken 5 questions, question number 11, 12, 13, 14 and 15. Okay then, let's start. Okay student, in question number 11, what they have asked, the plug setting of a negative sequence relay is this much, the current transfer ratio is given, the minimum value of line to line fault current for the operation of the relay. Now if you can see, plug setting is given 0.2, that is 0.2 is the secondary current for which relay will trip. Okay, so what is the ratio? Ratio is 1:5. So what will be the minimum fault current in the primary side if we go? So if we go for minimum fault current in the primary side for which it will trip, 0.2 is in secondary. 0.2 is in secondary. So in the primary it will be 5/1, that is 1 ampere. That means you can think it, if secondary is 1 ampere, then primary is 5 ampere. If secondary is 0.2, then primary will be how much? Normal unitary method, 5 into 0.2. That means for a fault current of 1 ampere that the relay will sense, fault current 1 ampere, it will trip. But here is a catch. What is the catch? Because this fault current, what is the relay? Relay is the negative sequence relay. So in the negative sequence relay, if it is a negative sequence relay, then the relay what is sensing is the negative sequence component of that relay. So the 1 ampere is nothing but it is the negative sequence component, that is I2 you can say. What is the fault current? That means this is not the fault current, this is the negative sequence component of that fault current. So if you can see from your symmetrical analysis, this was your IA0. So I am taking a standard line to line fault, that is a fault between B and C. So what is your IB? IB is equal to IF, which is equal to minus IC. You can think of this way. There are two lines, so B and C are shorted, so A is separated. So this is the fault current IF, which is nothing but IB, and which is nothing but IC, because fault current is flowing against C. So you can think of this. So what was IA0, IA1, IA2, and it was 1/3, 1, 1, 1, 1 alpha alpha square, 1 alpha square alpha, and then it is IA, IB, IC. Now which one is need? We need the second component. This is given as 1 ampere. This is the second component which we have calculated one, but we need to find the actual fault current. So it will be 1/3 of last one. So 1/3 of 1 IA. What is IA? IA is 0, IB is IF, and IC is minus IF. So let me write it. So 1 into 0, 0, plus alpha square into IF minus alpha into IF. So this is IA2, you have calculated how much from your relay setting. It is given as 1 ampere. Anything above 1 ampere it will trip. So it is 1/3, and it is alpha square minus alpha into IF. Now if you do alpha square minus alpha in calculator, you will find it. It is 1.732, as you can see, with an angle of minus 90. Angle is not required, that the magnitude is required here. So what will be your divided by 3? So 1.732 is nothing but root 3. So your IF is equal to 3 divided by root 3, multiply 3 divided by root 3, which is root 3 ampere, which is 1.732. Option C. So you can think it is, what was the idea? It is a negative sequence relay. So the relay what is measuring is a negative sequence component, not actual fault current. It is getting the negative sequence. So whatever you current getting 1 ampere, this is not the actual fault current, this is the negative sequence component of that fault current. The list of relays and the power system components protected by the relays are given by list 1, list 2. Choose the correct match from the any 4 choices given below. You can do it from here itself. If you can see, distance relay. Distance relay is generally given on transmission line, because distance relay. So distance relay, A is distance relay. So we know distance relay is given to transmission line, that is 6. So why it is transmission line? Because distance relay, you will give a impedance which is in proportional to the line. So transmission line, as you proceed towards the line, you go more length, then you will get more impedance. So accordingly that impedance given as the setting. So the impedance of transmission line is the set points of distance relay. So that's why it is in the transmission line. B, if you can see, under frequency from the options you can see, transformer, there is no need of under frequency. In transformer we have V by Z, volt hertz frequency for overfluxing, not only frequency. They compare V by F. So turbine is not in our scope. turbine is electrical or mechanical engineer, they will see. Obviously from electrical phenomena it will come. From if there is a change in speed. Bus bar, obviously bus bar is a concept of differential protection. Shunt capacitor, alternators. You can see alternators are the under frequency. If the frequency of the incoming, if the frequency of the voltage generator is not online, so we change that, we try to rectify that one, we try to bring it as frequency. So obviously B will be with your 5. So with this you can find the option, I think you can see option A is the correct answer, but still we will complete it. Then C is differential. Differential relay is connected for both, for your transformer also, for your bus bar also. So you can go either way. For bus bar also it is same concept. There is a bus bar and 2 line coming, so incoming and outgoing, they compare between these, what is the total current here, total current here. If there is any fault, then there will be mismatch between these 2 currents. So accordingly that concept is taken with some little bit modification in case of bus bar. So same differential concept is used in case of bus bar also. So C can be used for 3, and D is obviously, you know, it is for because relay is for transformer. So from here you can see option A is the correct option. Transmission line distance protection relay having property of being inherently directional. This one already you have seen in 1 year it came. So Moore relay you have already seen. I will give you again a link of this one in RX plane, and in BJ plane also you check the characteristics of Moore relay. It is always important. This is your forward quadrant. This quadrant is for backward fall, no space in. It is not occupying any area within, because inside is strip zone. So no area in third zone. So no backward fall, only forward fall it will sense. So it is inherently directional. In a biased differential relay, the bias is defined as the ratio of. So in a biased differential relay, you have already seen this is the property of the. In case of differential relay, if we don't want it to trip during external fall. So if your external fall current increases, but due to the CT error, the incoming and outgoing, this is the spill current. That is the current that is operating coil. So suppose this is your minimum level you have set, but your external fall current, as it increased, the spill current ideal case for any external fall, the spill current should be 0, because both current will be same, incoming outgoing will be same, fall is outside the periphery. I will give you the link, you can see, but as it increased, this keeps on increasing spill current due to the errors in CT feature, due to which the relay will trip after this point, so which is not desirable, due to which we give some biasing. So in biasing what we do, this line is not a fixed line, this becomes a straight line. So where you can change this slope. So you can change this slope means you can see now it is touching here, so it will trip after this much point. So you will get a better result for external fault. For a large external fall it will trip. So we don't want to trip it for any external fall, but we can increase the margin. So here here up to this much external fall it is not tripping, here up to, so you can increase it by increasing this K. So you can remember this formula. This was I1 minus I2. I will give you a link. K into I1 plus I2 by 2 plus K0, where this K is nothing but your biasing ratio. That means your spill current. This actually the idea was to bring a restraining torque, so that as your fall current, external fall current increases, the disc should have a torque in the opposite direction, so that it should not trip. So that opposite torque is given by this one. You can see the drawings of this biasing. I have explained it in details, this curve. I will give you the link. So K is the biasing factor, which is nothing but NR by N0, which is number of ratio of restraining coil and operating coil. You please check this one. This is a very good detailed explanation was there. Consider the transformer connections in a part of power system shown in the figure. Nature of transformer connections and phase shifts are indicated for all but except one. One is not shown. Which of the following connections and corresponding phase shift theta should be used for the transformer between A and B? So here is the figure. If you see the figure, this was the figure. So you can see from here to here, if you are coming, there is a 30. They have already given, but you should know this conversion. Why it is 30 degree, I have also explained it. You can think it in this way. If for remembering, just for memorizing, for the sake of memorization, I am giving a hint how to remember it, but it is not the actual way. Actual way to draw the phase. Delta means you can think of line, star means you can think of phase. So from line to you coming to phase, normally what you do in your whatever you have studied, your line voltage always leads your phase voltage by 30 degree. So from line, if you are coming to phase, there it should be minus 30, but in transformer it is reverse. That's all, you remember it like this. But here it is directly given. So from here also, if you from here to here if you come, it is minus 30. So from here to here if you go, it is plus 30. Suppose I am coming from here to up to this much, and I am also coming here this much. Let me see what is the shift. So if I come from here, there is a shift of 30 degree. 30 degree has positive increased from here to here. 30 degree increased, it added. So 30 degree, still it is 30 degree added. So from here side also it should be 30 degree added, because both are connected in same bus. So their magnitude and angle both should be same. So from here if I connect, you can see from here to here minus 30. So if I go from here to here, it is plus 30. So plus 30. So already 30 degree shifted. So what should be this shift so that it remains here? This is already 30 degree here. So this 30 degree is already, if you come from here to here, you came up to 30 degree. Now you are coming here, 30 degree is already done. So you need a change in 0 only, so that it remains at 30. You can understand now? From here if you are coming, then it is already 30 plus. 30 plus. So from here you are coming, already 30 plus is here. So you don't want to give anything extra. So if you give 0, it will be still 30 plus. So both will be same, you can connect it in a bus. So simply the answer is start, that is 0. You can see the answer, I have already done it here. If you like the video, then press the like button and please give your valuable comments in the comment section.